Still on balancing chemical equations, but in this part, this last part, I call it part 3, it's also going to be a very interesting part, all right? So in this part, we're going to look at a chemical equation that, well, you can use trial and error method, but that I am going to be quickly using the simultaneous equation method, all right? Stay tuned. So if you look at this chemical equation, it's a chemical reaction between hydrochloric acid and potassium heptaoxodichromate 6, and the result is giving us potassium chloride. This is chromium 3 chloride, this is chlorine gas, and this is water. All right. For the sake of this class, we are just focusing on balancing chemical equations. I know the questions in your heart could be, you've been balancing chemical equations and you are not including the physical states of the reactant and the product. All right. I could have included the physical states. All right, but we just want to focus on balancing chemical equations. That's why I don't really put priority to the physical states of each of the reactants and the products. Let's begin. All right, so look at the overall chemical equation. You would see that we have hydrogen, chlorine, potassium, chromium, and oxygen. The same thing in the product. All right, so for hydrogen, we will target H. The next we have chlorine. We will target Cl, and we have potassium. We will target K. Chromium, we will target Cr, and oxygen, we will target O. Yes, these are the 5 elements present in this chemical equation. That means we are going to have 5 chemical equations. This is going to be very interesting. All right. So hydrogen, remember, we are going to assign moles. This is A, this is B, this is C, this is D, and this is E and F. Yes. All right. So for hydrogen, 1 atom times A, so that is A. Any other hydrogen? No. Any other hydrogen? No, no, no. 2F. So A is equals to 2F. This is equation 1. The second equation for chlorine, 1 times A. So this is A equals to chlorine? No. Chlorine? Yes. 1 times C equals to C. Chlorine? Yes. 3 atoms of chlorine, that's in chromium 3 chloride, 3 times D, that's plus 3D. You can see here another chlorine, this is 2 times E, that's plus 2E. Any other chlorine? No, this is equation 2. Equation 2. Potassium, no. 2B, yes, I can see potassium there. 2B equals to 1 atom of potassium, that's C. 1 times C. Any other potassium atom? No, there's no other potassium atom there. So this is equation 3. Let's go to chromium now. Chromium, yes, I can see chromium here. 2 times B. So that is 2B equals to, no, chromium. Chromium, yes. 1 times D equals to D. That's equation 4. All right, I can see oxygen here. 7B. Oxygen, no. Oxygen, no. Oxygen, no. Oxygen, yes. 1 times F equals to f, equation 5. Equation 5. So you will see that we have 5 equations. Now, at this point, you can pause this video and look at this critically, because if you don't understand this part, you may miss it as we proceed. So, solution, remember the first thing to do, set A as 1. Set A as 1. So, if we say let A equals to 1, that means that and substituting this A into equation 1, you can see that equation 1, which says that A equals to 2F, A is equals to 2F, now becomes 1 equals to 2F. That means that F equals to 1 all over 2. Of course, you can see if you divide both sides by 2, 1 over 2 is equals to F. This means that F equals to 1 over 2. Right. So proceeding from there, we're going to look for another equation that can help us make use of variable A or variable F. Now, if you look at the list of the 5 equations, you will agree with me that the next possible equation that we'll begin to work with is equation 5. All right, because it is in equation 5 that we can easily make use of A that we found, or we use F. Obviously not A, it's going to be F. So substituting the value of F as 1 over 2 into equation 5, all right, which said that 7b is equals to F. So 7b equals to 1 all over 2. So by cross multiplication, you can see here that 14b equals to 1. So to find b, I'll divide both sides by 14, and b is obviously 1 over 14. b is obviously 1 all over 14. Now the next thing is, now we know what b is. A, F, and B. So which equation would help us to find another variable, to find the answer to another variable, all right, which represents moles, all right. So if we know the value of B, we can use equation 4, or we can also use equation 3. Yes, we can use equation 4 or equation 3, all right. Yeah. So, using equation 4 or using equation 3. Okay, let's use equation 3. Substituting B into equation 3. Equation 3 said that 2b is equals to C. That's equation 3. 2b is equals to C. So 2 into 1 over 14 equals to C. This means that 2 over 14 equals to C. This means that, of course, 2 cancel this out, 1 goes here 7. This means that C equals to 1 all over 7. So C is 1 all over 7. C is 1 all over 7. All right. Now, which other equation would any of these variables fit into that would help us to find A, B, C, to find D and E? Yes, to find D and E. Now, if you look at equation 2, you discover that we have D as a variable there, and we also have E as a variable there. So we can't go to equation 2. So the next equation now has to be equation 4. Has to be equation 4. Proceeding from there, equation 4 when we substitute b, this will become 2 into 1 over 14 equals to D. 2 into 1 over 14 equals to D. So looking at this, you will agree with me that the value of D will also be equals to 2 over 14, which is 1 over 7. So D is 1 all over 7. D is 1 all over 7. Alright. The equation remaining is equation 2. And the variable remaining is E. Let's find that. So substituting C, I'm substituting D into equation 2 will help us to find E. All right. Let's move. Equation 2, A equals to C plus 3D plus 2E. All right. So let's substitute. A is 1. C gives us 1 over 7 plus 3D, that's 3 into 1 over 7 plus 2E. Obviously, this is 1 equals to 1 all over 7 plus 3 all over 7 plus, this is 2E plus 2E. All right. So moving from there, you can do this and find E. All right. Just to test your knowledge. All right. Multiplying through by the LCM, we are going to have this LCM being 7. So multiplying 7 by the LCM, that is 1 times 7, that is 7. So this will be 1 over 7 times 7, that's 1. All right. This is 7 cancel 7, so that's 3. This is 2E times 7, that is 14E. Yes. Look at it again, so you get that. This cancels. All right. So this now becomes 7 equals to 4 plus 14 E. So which means 7 minus 4 equals to 14 E, meaning 3 equals to 14 E. Dividing both sides by 14, you see here that E equals to 3 all over 14. So the value of E is 3 all over 14. All right. So now we found A, we found B, we found C, D, E, and F. All right. Let's go back to our chemical equations. So from our chemical equations, we have found the value of A, B, C, D, E, and F. So let's impute it. All right. So this was 1, and B is 1 over 14, and this is my C, which is 1 over 7, and my D is 1 over 7. E is 3 over 14. And F is 1 over 7. F is 1 over 7. All right. So, like I said, we can't leave fractions as moles of a balanced chemical equation. So we are going to simplify it. We're going to break it out. So what's the LCM here? LCM, the denominator is 1, denominator is 14. 7, 14. So LCM is obviously 14. So I'm going to multiply all through by 14. So multiplying this by 14, I'm going to have 14 HCl plus 14 times 1 over 14. 14 times 1 over 14, of course, you know that 14 will cancel 14. All right, so what I will have left would be 1 K2Cl2O7. That's 1 mole of potassium heptaoxodichromate 6. So, which is written as just potassium heptaoxodichromate 6. All right, so the product now. I'm representing the product now. The product. All right, let me so the product, potassium chloride, I multiply by 14, so 7 goes here, 7 goes here, 1, this is 2. So what I am seeing here is 2 moles of potassium chloride. And the next, 1 over 7, 14 times 1 over 7 will give me 2, so this is 2 moles of chromium 3 chloride. All right, so the next is multiply this by 14, 14 times 3 over 14, of course 14 cancels out. What you have left is 3 moles of chlorine. 3 over 14, 14 times 3 all over 14, 14 cancels, all right? So what you have left is just 3. 14 times 1 over 7 moles of water would give you 2 moles of water. So you can see here that if this chemical equation must be balanced accurately, you must go through the simultaneous equation method. All right. If you check this, and you will agree with me that this is balanced. Now, look at this very well, because the value of f, look at this, let's correct this, please. The value of f we had was not 1 over 7. Was not 1 over 7. Let's look at this. The value of f we had was 1 over 2. So, I made a mistake, all right. So, 1 over 2, all right. So, it is 14 times 1 over 2. So, 2 goes here, 1, 2 goes here, 7. So, what we have here is 7 moles of water. Sorry about that. All right. Watch the video carefully and drop your comments in the comment section. Thank you so much. I believe you learned so much from that method of balancing simultaneous equations. So this is very helpful just in case you meet a complex chemical equation. You will not be doing trial and error. You just use the simultaneous equation method. Thank you. See you.